Our first session is going to start with a presentation on the problems with wildcatch and opportunities with alternatives. Our first speaker is Dr. Ling Cao, who together with myself and Michael Telesti authored she was the lead author on a paper that projected a scenario of what would happen if fish meal declines and timescales involved. Dr. Cao is now a professor at Xiamen University, another one of our F3 judges. She completed her PhD in natural resources and environment at University of Michigan. She's been trained as an agronomist and environmental scientist, focused on interdisciplinary research at the interface between the sustainability of food and natural systems. In 2021, Dr. Ling and her colleagues published a really well-cited 20-year retrospective of global aquaculture in nature that included a major focus on feed sustainability. Over the course of her career, Ling has established a long-term professional relationship with many of the leading aquafeed companies and stakeholders globally, but especially in China. So Ling, please.
Good morning. This is Ling from Xiamen U. I work on sustainable aquaculture policy and management, as Kevin just mentioned. First, I'd like to thank F3 for the invitation. And today, I'd like to share some findings from our most recent research on the vulnerability of global aquaculture to the potential shortage of forage fish, and discuss how the industry can better prepare to mitigate this risk. So the main issue of aquaculture is the feed issue, as we all know. And aquaculture largely depends on small pelagic forage fish, including sardines, anchovies, and herrings. Those fish are not only have important commercial value, but also are critical in the marine ecosystem. But natural factors and also human anthropocene activities can impact the wild forage fish populations, leading to their fluctuations. Main threats to wild forage fish include, for example, like pollution, overfishing, and climate change. And over the past 7 decades, global landings of forage fish have experienced significant shifts, rapidly increasing from 1950s to 1990s and peaking in 1994. And we see there's a pattern of considerable fluctuations and a general decline in forage fish landings. And the total landings of reduction fisheries that go to fish meal and fish oil production also have decreased significantly, almost dropped half from 29 million metric tons to 15 million metric tons. Additionally, the variety of species landed has more than doubled since the 1950s. While part of this trend may be because of the improved data resolution over time, maintaining the large forage fish supply, we can say now depends on harvesting more and more species. Our assessment of resources status for global forage fish reveals a widespread pattern of overexploitation. We see, in terms of stock numbers, nearly more than half of the stocks either come from overexploited or already collapsed species. And further analysis reveals the acute risk faced by forage fish we see a significant 10% of global landings of forage fish currently still come from overexploited and collapsed stocks. Areas, the FAO-defined areas such as Northwest Atlantic, Southeast Pacific areas are particularly alarming. And currently, aquaculture is still the main user of fish meal and forage and fish oil derived from forage fish. Globally, approximately about 75% of the fish oil and 69% of fish meal are used by aquaculture, with a remainder consumed by other sectors, for example, like the livestock and pet industry. And advances in fish nutrition and breeding have led to a significant reduction in fish meal inclusion rate in aqua feeds over the past 2 decades. We see even high-value species such as salmon and shrimp are increasingly use more and more plant-based proteins in their feed to replace fish meal and fish oil. And ASC, the certification standards requires forage fish dependency ratio of farm species to below 1.35. And we see currently only eels have FFDR exceeding 1. That means farming 1 kilogram of eels requires 2.3 kilograms of forage fish. However, if we look at the total consumption of forage fish, the total consumption, we simulate 12 main farmed taxa, main farmed aquaculture species. We observed a persistent upward trend in total forage fish consumption. This is mainly due to the expansion of aquaculture since the 1980s. And Kevin just mentioned the 2023, the cancellation of forage fish season in Peru, that led to a significant surge in fish meal and fish oil prices. And we see because Peru contributes 20% of the global fish meal and fish oil production. So this raises the question, what impact do the unstable supply and fluctuating price of fish meal and fish oil have on aquaculture and aquafeed industry? We developed 5 scenarios based on the stringent fisheries management and the climate impacts. And we also created a forage fish shortfall impact model to assess the effects of forage shortage on major farm species and aquaculture producing countries. Our results suggest that fisheries management interventions and climate change could reduce forage fish landings by 5 to 20%, resulting in 9% to 33% in global fed aquaculture production loss. Particularly, high-value species, high-value carnivorous species such as salmonids, eels, and milkfish will be most affected. And to sustain the 2022 levels of aquaculture production, fish meal inclusion rates must be decreased by more than half for many species, especially eels, salmonids, and milkfish. And the greatest lead for fish meal replacement is in salmonids and shrimp. And according to our modeling, a conservative estimate suggests that producing 1.8 million metric tons of alternative ingredients annually is essential to maintaining the continuity of global fed aquaculture. To summarize, I want to re-emphasize developing cost-effective alternative feeds that minimize the reliance of aquaculture on wild forage fish remains a present priority to enhance the resilience of aquaculture against global changes. Thank you.